Okay, so let's take a look. We should now be on the foldable. The front page looks like this. So what we're going to do is we're going to do that basic skill that we just learned. We're going to look at the angle, and we're going to use that angle to identify the sides of this triangle. So remember, the first thing I always like to do is identify that hypotenuse. So if we look, the hypotenuse is going to be opposite that right angle. So this must be the hypotenuse, and again I abbreviate that HYP. Then what we're going to do is jump over to that angle that we're given, that theta. I'm going to say, okay, well the opposite side needs to be across the triangle from that given angle. So this side, BC, is going to be my opposite side. And then finally our third side, this other side here, this is going to be next to that angle. So this must be the adjacent side. So we talked about sine, cosine, and tangent, and we said, well, those are our three trig functions. But what we haven't talked about is the actual ratios. So that's what we're going to talk about here on the front of the foldable. So we have those three ratios. We have sine, cosine, and tangent. So notice it says the sine, this is a function of the angle theta. So the sine of theta is going to be equal to the ratio of the opposite side over the hypotenuse. So it's going to be opposite over hypotenuse. So that's going to be our first ratio. And that's going to be for sine function. The cosine function, this ratio is always going to be the adjacent side over the hypotenuse. And then finally, we have the tangent side. So the tangent function, the tangent of our angle, it's important that this is our angle, same thing for all three trig functions. The tangent is going to be the opposite over the adjacent. Okay? So those are our three trig functions, sine, cosine, and tangent, and these are the ratios that they will equal. We need a way to memorize these three ratios. So pause the video now before I move on. Make sure you got all that down. If you got it, let's keep going. So we need a way to remember these ratios. If you remember, it was sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So what we need to do is, we got this little thing here, but we need a way to memorize this. So sorry guys, I was walking around. Oh, I hit my foot. Oh, ow, that really hurt. Oh. So what you guys have to remember is that if you broke a toa, you have to soak a toa. Alright, it's usually a little better when I'm in front of the class, but that's what I got for you guys. So remember, if you broke a toe, you gotta soak a toa. You get it? You know, like soak a toe. Alright, hopefully you enjoyed that. If not, you know, lame, whatever. We'll move on. But that's how you can remember it. Because the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. SOHCAHTOA. Alright, so hopefully that is a good way for you guys to remember it. What we need to do now is we need to look at how can we actually apply this to writing some equations out. So we're going to flip to the back of that foldable. So basically you're going to open up your foldable. We're going to look at number 1 together. So let's read the directions. Directions say, identify the sine, cosine, and tangent of both acute angles. So if we're looking at this triangle here, first thing we need to do is identify our acute angles. So the acute angles I see are angle X and angle Z. So what we need to do is we need to identify sine, cosine, and tangent of both of these angles. So what I would do is let's start with one angle and then work our way to the other angle. So let's start with angle x. So angle x, if I want to identify sine, cosine, and tangent, first thing I need to do is identify my sides using that basic skill of identifying the opposite, adjacent, and hypotenuse. So I'm going to come over here. From x, 15 is my opposite. 25 is my hypotenuse because it's opposite of that right angle. And then 20 must be the adjacent side. So to find the sine, cosine, and tangent, I'm going to look back at my ratios that we wrote on the front of the foldable there. And those ratios are the sine of my angle. In this case, I'm looking at angle x. So the sine of x is equal to the opposite side. So in this case, looking at x, the opposite side is 15 over the hypotenuse, and the hypotenuse of this triangle is that 25. So the sine of x is just 15 over 25. Now later on we're going to solve this equation for x, but for right now we're just setting up those ratios. We're writing the equation. Alright, so the next one, same thing. Now we want to do the cosine of that same angle x. We're going to do all the x first, then we'll get to the z. So cosine, if you guys look back to the front of the foldable, cosine is the adjacent side, so in this case 20 over 25. And then finally we have tangent. That's the third one they want us to find. The tangent of x. And if you look back at the front, that is the opposite side over the adjacent side. So it's just going to be 15 over 20. Now with each of these guys, you could simplify these fractions just to make it a little easier to smaller numbers to deal with. You could make this into 5 goes into both of them, so we could do 3 over 5. 5 goes into both of these, that becomes 4 over 5. 5 goes into both of these, this becomes 3 over 4. And that's perfectly fine to do that. It's actually better that way you know what is the reduced fraction for that ratio. Alright, so that is all of our trig functions for x. But now what we want to do is we're going to come to z and identify those trig functions. But before we do that, because z is at a different acute angle than x, we need to come here and figure out, well, what are these sides based from z? So first off, let's identify the hypotenuse. So for z, hypotenuse is still going to be the same. It's still the longest side in the triangle. Then I like to do my opposite. So I go from this angle z. I'm going to find the opposite side. So the opposite side in this case is the 20. Then the adjacent side is going to be 15. So notice how when I switched acute angles, I switched to opposite and adjacent, but the hypotenuse stayed the same. It's important because that tells you that it is very important on which angle that you're dealing with in the right triangle. And notice that we're only doing the acute angles and not the right angle. So in this class, we're not going to be doing any sine, cosines, and tangent of 90-degree angles. Save that for pre-calc. So now that we've got sine, cosine, tangent for angle x, let's take a look and get sine, cosine, and tangent for angle z. So notice that I'm writing the angle inside those parentheses after the trig function. Do the same thing for each one. Cosine of z, sine of z, and tangent of z. The angle always goes with your trig function. Angle always goes with your trig function for each one. Let's write these ratios now. If you remember, sine is the opposite over the hypotenuse. Now be careful. We're going from angle z, so we got to go to the opposite of angle z, which is 20, over the hypotenuse, which stays the same because it's still the longest side no matter what acute angle I look at, 25. Same thing, cosine of z. We take a look at that one. Cosine of angle z, so we're starting at angle z, so we need cosine, which is the adjacent over the hypotenuse. Adjacent side 15, hypotenuse 25. And then finally we need our last one, tangent function. That one, again from angle z, is going to be the opposite over the adjacent. TOA, remember in SOHCAHTOA, TOA is OA, so opposite over adjacent, 20 over 15. Now from here, if we want to, again, we can reduce these fractions just to make the numbers a little easier to deal with. 20 over 25, that's going to be 4 over 5. You guys, you don't have to do this reducing, but it does help you later on when we're actually solving the equations. 15 over 25 is going to be 3 over 5. And then tangent of z, 20 over 15, is going to be 4 over 3. Now, before we move on, I want to take a look at the relationship between the angle x and the angle z functions. So if you look at x, the sine of x was 3/5. If we look at the sine of z, that was 4/5. So they're not the same, and they shouldn't be the same. It's two different acute angles. But notice that the sine of x here is the same as the cosine of z. You see how they are both 3/5? That's an important thing. So what that tells me is that the sine of one acute angle is equal to the cosine of the other. So we can say the sine of x is always going to equal the cosine of z. So the sine of one acute angle is equal to the cosine of the other. Let's see if that works the other way around. Does that work for the cosine of x, which we said was 4/5? Is that the same as the sine of z? Yeah, it is. So we can also say that the cosine of x is equal to the sine of z. So if you look at that, really that's the same relationship, just listed in a different order. The sine of one angle is equal to the cosine of the other angle. Same vice versa works. The cosine of one angle is equal to the sine of the other angle. So that's an important relationship. They're going to ask you questions like, if the sine of x is 4/5, what's the cosine of z? And you guys would then know that it's also that 4/5. Now this last one, this one with the tangent, this one's a little interesting. So tangents aren't going to be equal to each other, and they shouldn't be because it's two separate angles. But what happens is we started with 3/4 for the tangent of x, but if you look, it flipped, and the tangent of z was 4/3. So for the tangent functions, for tangents, the opposite angle, or the different acute angles, are reciprocals of each other. Reciprocals meaning they flipped, if you guys remember that. It's right down below. Reciprocals. Okay, so what all this means is that if you know these three, you don't need to do any other work for these three. You just know that the sine of this one's going to be the cosine of the other angle. The cosine of this one's going to be the sine of the other angle. And you can just write down those numbers. You don't have to do the work. You know, if the tangent of one angle is 3/4, the tangent of the other angle is going to be the reciprocal. So it kind of saves you a little bit of thinking if you can memorize these properties. All right, so let's take a look. What I want you guys to do is using this as an example. So if you don't have it, pause now because I'm going to move to the next page. Get that down. I want you guys to try number 3 on that paper. I want you to find the sine, cosine, tangent of both acute angles. So in this case, you would have angle C and angle A that you need to find the sine, cosine, and tangent of. So go ahead and pause. I'd say maybe take about 5 minutes. Try that out, and then come on back to check your answers. All right, so here's the answers that you should have gotten for this. Again, guys, all I did was I identified the opposite and adjacent and hypotenuse for the angle A, so these ones, and then from there, once I found that out, I used my trig ratios to figure out these fractions here. Then I knew that if I go to the opposite angle, I'm going to use that property that says, well, the sine of one angle is equal to the cosine of the other, so that means the cosine of C must be 3/5, and the sine of C must be 4/5 because that's going to be equal to the cosine of the other angle. And then I remembered that with tangent functions, the opposite angle is just the reciprocal of that. Now, if you forgot that, and that's fine if you don't have it memorized, you still just used your SOHCAHTOA. Sine is the opposite of hypotenuse. cosine is the adjacent over the hypotenuse, and actually I like to write these like this. Adjacent over hypotenuse, and tangent is the opposite over adjacent. So you can still use your SOHCAHTOA. Remember, if you broke a TOA, you got a SOHCAHTOA. Memorize that, and then all you'd have to do is just fill in your parts based off of what you got labeled in your triangle over here. So all we need to do now is we're going to end this video. If you need to take a minute to finish getting down this answer, that's fine. Pause. If not, we're going to finish this video and start the next one, and we're going to start that video back on that notes sheet. So if you want to head back over that notes sheet, this would be a good time to do it.